boys, so we're going to do some practice with the probability that we've been learning. So these are different questions, we'll see how we go. So the first one, Sally flipped a coin 7 times and a tail showed each time. What is the chance of a tail showing on the next toss? Now, this is what gamblers do. They think, okay, this has been tails every time. It's got to come up heads sometime. I'm going to put my money on heads coming up next time. And really, it doesn't make any difference. It doesn't matter what happened before. You just look at that coin. It's got heads and it's got tails on it. You do a flip, whether it's the first time or it's the 108th time or it's the 1000th time, the chance of it coming up on tails is still 1 out of 2. That is irrelevant what's happened beforehand, okay? So don't get tricked on those questions. All right, now number 2. We have a computer selected a random number from 1 to 15 inclusive. Inclusive means that it can include the 1 and it can include the 15. So we have 15 numbers. Find the probability, make sure you underline that the number is odd. The best way to do these questions is to write down all the odd numbers. So we have 1, 3, 5, 7, 9, 11, 13 and 15. Then count them up. 1, 2, 3, 4, 5, 6, 7, 8 odd numbers. Put that down on the top. Out of 15 numbers altogether. And that's your answer. That won't simplify. You can put it in your fraction key in your calculator. You'll find it won't simplify. Okay, the next one. We're looking at probability of not prime numbers. So remember that prime numbers are numbers that have 2 factors. Okay? So if it doesn't have 2 factors, then it's not prime. So if we look at each number one at a time, number 1 is not prime because it only has 1 factor. Number 2 is not prime. Number 2 is prime. I'll get rid of that. Number 2 is prime because it's got 2 factors, 1 and 2. Number 3 is prime because it's got 2 factors, 1 and 3. Number 4 is not prime because it's got a number of factors. 2 goes into it, for instance. Number 5 is prime because it has 2 factors, 1 and 5. Number 6 is not prime because 2 and 3 go into that. There's lots of numbers that go into 6. 7 is prime because it does have 2 factors. 8 is not prime. 9 is not prime because 3 goes into that. 10 is not prime. 11 is prime because it has 1 and 11 as its factors. 12 is not. 13 is prime because it's only 1 and 13 that go into 13. 14 is not prime. And 15 is not prime because 3 and 5 go into 15. So let's count up all these numbers that are not prime. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 out of 15 numbers. Now if you put that in your fraction key on your calculator, it will simplify down to 3 over 5. All right, the next one, we're looking at numbers that are multiples of 3 or 5. So if we do them one at a time, the multiples of 3 are 3, 6, 9, 12 and 15. The multiples of 5 are 5, 10 and 15. Now you can't include any number twice. So we already have a 15, so we're going to cross this one out. But everything else has only been written once. So now we can count them up. 1, 2, 3, 4, 5, 6, 7. So it's 7 numbers that are multiples of 3 or 5 out of 15 numbers. And that will not simplify. Okay, the next one we're looking at is a factor of 12. So I'll list all the factors of 12. All the numbers that go into 12. 1 goes into 12, 2 goes into 12, 3 goes into 12, 4 goes into 12, 5 does not, 6 goes into 12. And by the time you get there, you'll see you're actually starting to pair them up. 3 times 4 is 12, 2 times 6 is 12, 1 times 12 is 12. So now we count them. 1, 2, 3, 4, 5, 6. So we've got 6 factors of 12 out of 15 numbers. If you put that in your calculator and simplify it, it will come down to 2 over 5. All right, now this next question is hard. You can mark this question as a hard question. So there's a lot to think about here, and if they want to test you out in a test about who's actually a Newman Standard person, then you're going to have to understand these sorts of questions. So we have 40 students at a school camp. They can select kayaking or bushwalking as an activity or both. A total of 35 students chose kayaking, 20 chose bushwalking, including some who chose both. All students chose an activity. So we're going to draw a Venn diagram. I'll show you how to go about this. The hardest part on this is starting it. So firstly, we're going to draw the Venn diagram up with 2 circles, one with kayak and one with bushwalking. Now, if you have a look at these numbers, something looks wrong. We have 40 students. Then if you have a look at what they've told you, they've accounted for 35 students and another 20 students. So it looks like we've actually got 35 students and 20 students. That's 55 students. But we're supposed to only have 40. So that's why we've got interlocking circles over there with an overlap. So the first thing you need to do is find that overlap. So we're going to do the 35 plus 20. If we add those up, we get 55. So it looks like we've got too many students. There's supposed to only be 40 students. So we're going to take off that 40. Now if we do that, we get 15. And they must be the students who chose both. So that's going to go into here. So those 15 go in there. Now the rest of it should be okay once you've got that sorted out. So now let's have another look at what they're telling us. A total of 35 students chose kayaking. Now you've already got 15 people in the kayaking circle. We need another 20 to put the rest in. So to get that number there, you're just doing the 35 minus 15. 35 students chose kayaking. 15 were already in the kayaking circle. You're writing down what's left. Now, with the other one, they said 20 chose bushwalking. So if you have a look at what's happening over there, we've already got 15 people in the bushwalking circle. But they tell us that 20 people chose it. So if we do 20 take away the 15, you'll get 5 people in the bushwalking circle that did not end up in the overlap. Now, if you were at the end of your test and you wanted to check this, you just make sure that you've got 40 students in your Venn diagram. So if we do 20 plus 15 plus 5, add those up on your calculator now, you'll find that you do have 40 students and the Venn diagram must be correct. Okay, now we're down to doing this part. So from our Venn diagram, we're going to answer these probability questions. So if you get into a test and they have a question like this, and you're a bit lost on drawing a Venn diagram, like I've told you before, make up some numbers to go in there. Because then you can use those numbers to do these questions down here and you will not be penalised. Okay, you'll only be penalised for your wrong Venn diagram. All right, so let's have a look at it. What's the probability that a student chose both activities? Well, the people that chose both are in the overlap there. So there's 15 of them. And we know there's 40 students in the total number of students. We'll put that there. Put that in your fraction key on your calculator and simplify it. And you'll end up with 3/8. Now down the bottom here, we want the ones that did not choose bushwalking. Right, so the probability that they're not bushwalking. So we want to have a look at anyone who is not in the bushwalking circle. So it's just these 20 here that just chose kayaking. So we put them on the top, and the total number of students is 40. That goes on the bottom. And on your calculator, when you simplify it, you're going to get 1/2. So I'm going to come back in the next video and just do one more example to practice a few things.